Hello, class. So, all matter is made out of one thing. Do you know what it is? That's right. If you guessed atoms, you're correct. And every single atom can be in the state of either a solid, liquid, or gas. So let's begin with some notes. We mentioned that the states of matter are solids, liquids, and gases. There is a fourth one called plasma, but we are not going to be studying that one. So, how do states of matter differ? There are actually differences depending on whether or not it is a solid, liquid, or gas. How much space between the atoms exists is different for a solid, liquid, or gas. So, example, you can have atoms that are very close, or you can have atoms that have a lot of space in between. How the atoms are arranged. Atoms are arranged differently if it is a solid, liquid, or gas. So, for example, you'll see here that the atoms are fairly close together and stacked on top of each other, whereas over here, they are kind of disordered. There's some space in between some of the atoms, but some of the atoms are actually very close. It looks similar to this one over here on the left, however, a little bit different. How the atoms move is also specific whether or not it is a solid, liquid, or gas. So for example, you have here two atoms, and they're moving back and forth between each other, and they tend to stop right in the center and go right back and forth. Versus, here is another example where the atoms are just going in whatever direction they want. Another way that states of matter are different is how much energy each atom has. And however much energy each atom has can either be denoted as low, medium, or high. So, please begin by drawing this data table. It's kind of big, but use up a lot of space for it. You're going to be drawing some pictures, and you're also going to be describing the shape, volume of the particles, and you're also going to be describing particle movement. And these are for all of the three states, solid, liquids, and gas. Now, for a solid, it has a low level of energy. The atoms are almost still, but they're moving. If you were to look close enough, they are actually moving. This chair that you're sitting on is moving, even though you don't notice that it isn't. So, if we were to draw the particles in a closed container, and notice that this is my closed container, if this was my solid, the particles inside of this object would actually be going back and forth, kind of like sitting still, but just going back and forth, back and forth, back and forth. Between the particles, these two atoms are very attracted to each other. They have a high level of attraction between each other, and they keep dancing towards each other. But when they get really close, they pull apart. And then they go back, and they pull apart. And they go back, and they pull apart. So it's kind of like this dance. To describe the shape or the volume of the particles keep its original shape, and they keep their structure. That's why when you have a cube, it stays a cube no matter where you put it. If you put it into a container, it stays the shape of a cube. Now, one of the things I mentioned was how the particles move. The atoms attract and repel each other. They're kind of doing this dance, this pull and push, this pull and push. And they don't touch. Let's move on to liquids. Liquids, now in order to get from a solid to a liquid, you have to add heat. And when you add heat, it raises the energy level of the liquid. So the energy level of this is going to be medium energy. It's starting to increase its level of energy. When we draw this picture of liquid in a container, you'll notice that the liquid stays at the bottom of the container, and if you were to continue to fill it up, it would go all the way up to the top. So, atoms take the shape of the bottom of the container and it goes up. There is no order at all except for that it keeps the shape of the container at the bottom. There is no real structure. The particles inside of the liquid slip and slide and bump. They are close together, but again, they don't per se touch. No atom really touches each other. They merely get close and they repel each other. But this is a little bit different because you'll notice that when you take a container with liquid and you move it side to side, it will always slosh to the direction that you're tipping the container. Now, let's go on to gas. Gas has a high energy level. So if you were to take liquid and boil it, you would evaporate the atoms and they would be shooting out. They would go straight from liquid to gas, and they have so much energy and they have a lot of freedom. So they are like Superman and they're flying in all the different directions. And notice this is the container, so they're going to fly in a certain direction until they bump into something and then they go boing, 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 boing all over the place. So the shape that the particles take is the entire shape of the container. There is no order at all. So if you notice in solids, the level of order decreases as the energy level increases. Pretty cool. Now, the particle movement we described was that there is a lot of space in between the particles and that they travel in one direction until it bumps into something else. Let me show you a really quick video or a simulation of what a solid looks like. So here, notice that the solids are moving back and forth, and they stay very still. They're very attracted to each other. But as we add heat, so notice the temperature is starting to increase. And now we have liquids, and they're bumping and sliding all over the place. There is no real structure, there's no order, but it stays in the bottom of the container. If we add more heat, and now we're turning the liquid into a gas, you will notice that the particles are just flying around, and that is the gas. So, that is the end of our notes. Please feel free to go back and listen to anything that you might have missed, and we'll see you in class.